So in this lesson, we are going to tackle the word problems. So by now, you're able to solve a linear system algebraically and graphically, but of course, in this lesson, we are going to solve it algebraically, either by substitution or elimination. The four main types of word problems we are going to tackle in this unit are coin problems, investment problems, mixture problems, and rate problems. Now, I personally hate to dice up my word problems into different categories, but many students find that helpful. What I prefer is to read the question and devise the correct strategy appropriately. Okay, so I really don't like to dice them up, because on the test or quiz, you can get word problems that don't fall under one of these types. So they're like, for example, they're number problems, or they're geometry problems when you talk about a triangle or a rectangle. So lots of other different types of problems. So I prefer to just talk about the general strategy when I see these linear system word problems. So I read the question, write the let statements, generate the linear system that corresponds to the word problem. That's actually the hardest part, generating the correct linear system that matches your word problem. And then the solving part's easy. Interpreting solution is pretty easy as well. So if you've mastered your ability to solve a system, then we're ready to go. All right, so coin problems, the first of four types. I think that most students agree that this is the easiest type of problem that we are going to tackle in this unit. So Bobby has $7.50 worth of dimes and nickels. He has 100 coins in total. How many nickels does he have, and how many dimes does he have? Okay, so we have really two facts that's provided in the question. We have the fact that he has $7.50 worth of dimes and nickels, and he has 100 coins. So using these two facts, you can build two linear equations. Two facts, two linear equations, make up the linear system, and then solve the system. Some students like to build a table to help organize the information, so go ahead, you can do that as well. So I'm just gonna write down the first fact that comes to mind is that the number of nickels and the number of dimes, the sum of the number is 100. He has 100 coins in total. So that's my first equation. N plus D equals 100. My second equation is based on the total value. I know each nickel is 5 cents. And I also know each dime is 10 cents. So this is the total value from the nickels. So 5 cents times the number of nickels plus 10 cents times the number of dimes. And the total value is $7.50. Okay, I'm going to write a nice let statement here. Let N represent number of nickels. So please don't write let N represent nickels. Okay, a good let statement will really help you understand the solution that you get from your linear system. So please take your time and write a nice let statement. The extra few seconds will really help down the road. Let D represent, not dimes, the number of dimes. Okay? In fact, you can say number of dimes. Yeah, he has. Okay, so time to solve the system. This was the hard part. Okay? Solving should be the easy part. So you can choose elimination, substitution, it doesn't really matter. I'm going to save myself some time, and I'll let you do the I'll let you solve this system, but I will tell you the solution. You can do this on your own time. Let's see. Oh, interesting. He has 50 dimes and 50 nickels. Okay, if you have problems solving this, you can email me or just post a comment. So for all these word problems, I'm going to make the assumption that you can solve a linear system. If you cannot solve a linear system either by substitution or elimination, you need to review that and then come back to word problems, because there's really no point in building a system that you can't solve. All right, so Felix has $9 worth of quarters and loonies. He has 15 coins in total. How many quarters does he have? How many loonies does he have? So I'm going to write my let statement first. Let L represent number of loonies. Let Q represent number of quarters. Okay. All right. So there's two facts. The sum of the values from the quarters and loonies is $9, and the fact that there are 15 coins in total. So that will allow me to build a linear system. So the first fact I think is pretty easy. The number of loonies plus the number of quarters is 15. And the total value from the loonies and quarters is $9. So L plus 0.25Q equals 9. Okay, so some students actually like to prefer to write an alternative of equation 2. So, or you can do 100L plus 25Q equals 900. So this is in cents now, because quarter is 25 cents and loonie is 100 cents and $9 is 900 cents. So it's up to you which equation you build, but these are equivalent linear equations, which means if I write this, these are equivalent linear systems. Yes, the second equation does look different, but the solution to both the systems will be the same. So just like before, I'm going to solve it very quickly. Let's see. So there are 7 loonies and 8 quarters. Okay, so hope you can solve that correctly. So it doesn't matter, substitution, elimination, pick whatever you're comfortable. But if it's specified on the test, then you have to do it whichever way is stated. Okay, so the second kind of problem that we're going to talk about are investment problems. So Sherry invested a total of $1,000 in 2 companies, Apple and Nike. She earned $142. And this should be after, everything's after 1 year. So she earned $142 after 1 year. The return on the Apple stock was 7% for the year, and while the return on the Nike stock was 15% for the year. How much did he invest in each stock? It's actually she. It's okay. So once again, we can put a chart here. Organize information. But as you get more practice, you'll find that you don't need the chart. You can just really extract the 2 equations while you read it. Okay, so the easiest equation I think is x plus y equals 1,000. Okay, so when I write the let statement, this equation is going to make much more sense. So let x represent amount invested at 7% per year. Let y represent amount invested at 15% per year. Okay, that's the return. 15%, well, they're both really good returns, to be honest with you. Okay, so she invested in dollars. So let's make sure we write that, okay? They're not pesos, they're not yen, dollars, okay? So x plus y equals 1,000, which means the amount invested at 7% plus the amount invested at 15%, that's $1,000, right? So it makes perfect sense. Now the other equation, so the amount she gets from the 7% account, okay, which is 0.07x, and the amount she gets from the 15% account, which is 0.15y. So the amount she gets from both accounts must be equal to 142. Okay, this is the amount of money she gets from the Apple stock. This is the amount she invested, or the money she receives from the Nike stock. And of course, the total money she gets from both the stocks is $142 for that year. Okay, therefore, She invested, I'll quickly solve it. Okay, ooh, she invested $100 in Apple. I forgot, you could have just, instead of saying at 7% per year, amount invested in Nike would be great as well. And let Y represent amount invested in, sorry, at 7%. So the first, let X represent amount invested at, or in Apple, let Y represent amount invested in Nike. Okay, so if it's 1,000 in Apple, that must mean she invested 900 in the 15% return account, which is Nike. Okay. All right. Lucy invested exactly $6,000 exactly 1 year ago. Okay, 5% from one account and 10% from the other account. She earns a total of $550 in interest over that 1 year. So how much does she put in each investment? So let X represent amount invested at 5% interest. Let Y represent amount invested at 10% interest. Okay, so now the first equation, I think the easiest one is to say X plus Y, the total amount invested, is $6,000. Beautiful. Okay, now the second equation, little harder than the first one, but hopefully you can see that the account, the first investment earning 5%, so it's 0.05x. This is how much she earns from the 5% account, and then there's one that earns 10%. Okay, so the total amount that she gets is 5% from the 5% account and 10% from the 10% account. If you total that together, you should get $550. The interest from both accounts totals to $550. Okay, you know what? It's time to think about this. Before I even solve it, I like to have an idea of what my solution should be. Did she invest more in the 5% account, or did she invest more in the 10% account? Okay, so I like to think about it first. If she earned $550, well, let's see. If she earned exactly, if she invested $3,000 evenly in both accounts, okay? If she invested $3,000 in both accounts, this is the return, $450. Okay, 5% from 3,000 and 10% of 3,000, because you invested 3,000 into each account. Okay, that's a perfect split. What was the answer? It was 450. But your actual return is 550, which means you invested more in the 10% account and less in the 5% account. So I don't know what the solution is, but based on the provided information, I know I'm investing more in the 10% account. Okay, so sometimes before I solve a linear system, I like to have an idea of what the solution is, and when I do solve it, I get a very good feeling about my solution. I like to think about the solution before I solve the solution or solve the system. Okay, so I will get ready to solve it now. But I know I invested more at 10%. Yes, I did. She invested $1,000 at 5% interest, and which means she invested $5,000 at, let's see, 10% interest, which is what we said was going to happen. She invested more at 10%. Okay, she invested more at 10%. That's the only way to get this $550 in combined interest. The only way to do so is if she invested more in the 10% account and less in the 5% account. It cannot be an even split. Okay. All right, so mixture problems. So Berta has a bottle of 5% acid and a 10% acid. Okay, so it means 5% of this volume is pure acid and 10% of this volume is pure acid. She wants to make 250 mils of 8% acid. So you have something that's rather weak and something that's rather strong. If you mix it together, you get something in between. So the question here, before I even start answering it, okay, I want an idea of the solution. Did she use more of the 5% or the 10%? Well, guess what? If she used exactly the same amount of both, the 5% and the 10%, guess what? You're going to meet halfway in between, which is 7.5. But since the mixture is 8% acid, that must mean you use slightly more of the 10% stuff compared to the 5% stuff. Okay? All right. So, you know what? Let's write out that statement first. Let X represent volume of 5% acid used. Okay, please don't write let X rep 5% acid. Okay, it's a good let statement really helps you understand the problem. Okay, it's the volume of the 5% acid used to generate this 250 milliliter mixture, and it's in milliliters. Let Y represent volume of 10% acid used in the mixture. Okay, all right. I think the easy equation is the first one I'm going to write. The volume that you use from the 5% acid and the volume of the 10% acid, the total volume must be 250 milliliters. Most students get this first equation correct for the system. It's the second equation that really trips up the students. Okay, I'll write down what most students write. So I'm going to make a mistake on purpose. So 0.05x plus 0.01. Okay, 0.1y. That was not the intentional mistake. Okay, so 0.05x plus 0.1y is equal to 250. That's what a lot of students write, okay? And I know why students write this, but first let me explain why it's wrong, okay? So you take X, the volume of the 5% acid used, and you multiply by 0.05. So this is pure acid. Pure acid from 5% acid. And this one, 0.1y, is the pure acid from 10% acid. So you're telling me that the pure acid from the 5% acid and the pure acid from the 10% acid is equal to 250 mils? No, that's not what you're thinking. Because your mixture is only 8% acid. Your mixture is 8% acid. So of this 250 mils, you should multiply by 0.08, right? 8% of the 250 mils is pure acid. Okay, so please don't, this is the most common mistake, taking the 250 and multiplying by 0.08. Huge difference. Okay, you're trying to say, because the mixture is 8% acid, you have to take 250 and multiply by 0.08. You know what? Let's find out what that is. So there's 20 mils of pure acid. 20 mils of the 250, 20 mils is pure acid. It's coming from the 5% stuff and the 10% stuff. Now, the reason why students write 250 and not 250 times 0.08, I think, well, one of the reasons just because of an oversight. They just don't think of multiplying by 0.08. But I think the other problem is because you're thinking of investment problems, okay? Because their investment problems and mixture problems are actually very similar. So I think the logic here doesn't transfer completely over. You just forget to multiply by 0.08. So yeah, I'd say that's a small difference with mixture problems where you have to take that total volume and multiply by 0.08. Whereas an investment problem, you just know what your return is. There's no need to multiply. Okay, with that said, let's just find a solution to this system. All right, so therefore, she should use 100 mils of 5% acid and 150 mils of 10% acid. And guess what? That's exactly what we said in the beginning. We said she should use more of the 10% stuff than the 5% stuff to make it 8% stuff. Yep. So this corresponds to what I thought originally. Okay, it's like I said, it's really helpful to think about what the solution should be prior to finding a solution. So when you do find it, it corresponds to the just pure logic. And I also want to add, good let statement really helps you write a good therefore statement. Okay, because if you wrote let x rep 5% acid, it just doesn't make any sense. Okay, all right. Amy needs to make 10 liters of 42% sulfuric acid solution. She finds 2 bottles, 30% stuff and 60% stuff. If you mix to 2, it gets somewhere in between. So we want to make a 42% solution. All right. So once again, I'm going to quickly find out, did I use more of the 30% stuff or the 60% stuff? Well, if I use exactly the same amount of each, I'm going to get halfway between 30 and 60, which is 45. Now I'm not making 45% solution, I'm making a 42% solution, which means I'm going to use a little bit more of the 30% stuff, okay, because 42 is closer to 30 than 60. All right, so let's build the 2 equations. The first equation I think everyone's going to get, x plus y equals 10 liters, okay? So you know what, I think it's a good time to write our let statement before we get too excited here. Let x represent volume of 30% sulfuric acid solution used. That's in liters. And then the y's represent the amount or the volume of 60% sulfuric acid solution used. All right, so this is the one that worries me, the second equation. So 30%, so that's the pure acid from the 30% sulfuric acid solution, and then 60%. And what is the total acid in the mixture? 42% of 10, which is 4.2 liters. Of that 10 liters, 4.2 liters is pure acid. All right, so that means therefore she used 6 liters of 30% sulfuric acid and 4 liters of 60% sulfuric acid. This is what we said earlier. She used more of the 30% stuff than the 60% stuff. Perfect. All right. Now let's do some rate problems here. So we're going to dice up the rate problems into 2 types. Like I said in the very beginning, I hate to divide my word problems, but it helps. Students really prefer that. Okay, I think it's because the problem solving skills aren't as strong in the beginning, so we need a lot of scaffolding. But anyways, really try to generalize the ideas. Okay, all you're really doing is building a system. Okay, so rate problems. This is the first kind of rate problem we're going to do. There's 2 trips. Okay, you make a trip that has a force pushing with your direction, and then you have to go against that force afterwards. So for example, if you're on a boat and you're going with the current, and then you have to go against the current. Okay, or if you think about if you're a plane, you're going with the wind for one trip, and then you have to go against the wind on the trip back. Okay, so you have a remote control boat, speeds down 100-meter section in 12.5 seconds. It goes up the same section, but it takes 50 seconds. How fast is the river current? How fast is the boat traveling with no current? Okay, so one thing before we do these rate problems, you have to remember what you learned in grade 9. Speed equals distance over time, okay? V equals d over t. So that is very important. And of course, any arrangement of this will be useful. So for example, distance is speed times time. Or you can say time is distance over speed. Okay, so once again, we have a table here. When you're going downstream, so with the current, your speed is the boat with the current. You're basically going much faster. And if you're going upstream, you're going a little bit slower because now your boat, the speed is the boat subtracted by the speed of the current. So using your speed, your speed equals distance over time formula. So B plus C is equal to 100 distance over time 12.5. Okay, the sum of the boat in still water or no current plus the speed of the current is 100 over 12.5, and then the other speed would be the same distance, but whoa, it takes 50 seconds instead. Okay, so let's do a therefore statement. Let B represent speed of boat in still water, or you can say with no current. Both really mean the same thing. And we're doing kilometers per hour, or sorry, meters per second. Let's see rep speed of current in meters per second. All right, so I'm assuming you can solve a system. So therefore, the boat with no current travels at 5 meters per second, and the current is 3 meters per second. The current's actually very strong. Okay, one more here. Aang travels 3,000 kilometers to fight the evil Fire Lord. It takes him 25 hours to fly there with the wind and 37.5 hours against the wind. So we have Aang with the wind. It's going to be 3,000 kilometers. Speed equals, this is the speed, the combined speed when he's going with the wind over distance equals distance over time. Now if he's going against the wind, to subtract by the wind, it's going to be 3,000 over 37.5. Okay, let A represent speed of Aang in still air, so with no current, so that would be kilometers per hour. And then let W represent speed of current, let's say wind, sorry, wind, kilometer per hour. All right, let's see, what's the answer here? 1. Okay, so therefore Aang in still air is 100 kilometers per hour, and the wind is 20 kilometers per hour. All right. Last kind of rate problem we're going to talk about. There are actually more kinds of rate problems, but we really can't cover everything. Okay, so the general idea here is just to build your ability to generate a system, and then once you have that ability, you can solve pretty much all types of word problems. Okay, so we're just kind of getting in the groove of building linear systems. Okay, so this kind of rate problem involves you have two parts to a trip. Okay, so let's just read the first part. Our first question: Bob went by plane and train from Pleasantville to Springfield, a total distance of 1575 kilometers. Bob spent 3 hours less on the plane traveling 325 kilometers per hour than he did on the train traveling 100 kilometers per hour. Okay, how long did he spend on the plane and on the train? Okay, let's do our let statements first. Let T represent time on train. Okay, let P represent time on plane. Okay, so the total distance, how did I get 100t in this table? Well, because like I said, if speed is equal to distance over time, then distance is speed times time. And the distance covered by train and the distance covered by plane must be, in this case, 1,575. Okay, so the next equation is coming from the fact that Bob spent 3 hours less on the plane than on the train. So this is what I like to do, because students usually have a hard time with this. So what I do is I build an equation, which is wrong, but we'll fix it. So T equals P. This would mean that the time on the train is equal to the time on the plane. But that's not the case. If Bob spent 3 hours less on the plane, so this number here is lesser. Okay, so this is lesser. So let me just, this is lesser. So to make them equal, I either take the right side of my equation, add by 3, or I take the left side of my equation and subtract by 3. Okay, I'm going to choose to take the plane time and add by 3, because if Bob spent 3 hours less on the plane, I can make it equal by taking the plane time and adding by 3, and then I'm going to have the right equation. Okay, let's see if I can solve this here. So 1, -1. Okay, so therefore Bob was on the train for 6 hours and plane for 3 hours, because it's 3 less than the train. Okay, there we go. Last one. So we have a biathlete travels 175 kilometers by bike and by foot. She rides on a bike for 1 hour longer than she runs on foot. If she runs 20 kilometers per hour, wow, that's fast, and bikes at 40 kilometers per hour, how long was she running and how long was she biking? So let B represent time biking in hours. Let F represent time on foot. Okay, so I'm going to build the first equation, which is the total time, the total distance. So speed is equal to distance over time, so distance is speed times time. So biking is 40b plus 20f is equal to 175. Okay, and she rides 1 hour longer, right? So she rides on a bike for 1 hour longer than the foot. So right now, the bike is, this number here is 1 greater than the right side of my equation. So the only way to make this equal is if I take the left side, subtract by 1, or I take the right side and add by 1. Okay, so bam, there we go. She bikes for 1 hour longer than on foot. So since this number here, I don't know what it is, but it's 1 smaller than B, so I'm going to take it, add by 1, and there's my beautiful equation. Okay, I'm going to solve a system real quick. So we have 40, 20. Okay, therefore, she biked for 3.25 hours and was on foot for 2.25 hours. Beautiful. Okay, so we tackled quite a few different types of word problems, but I really want you to get comfortable with the word problems and try not to dice them up, okay? When you see a problem, I don't want you to do it by memory. I want you to just approach it like any other problem and just solve it. Build a system, think about the facts that are provided in the problem, and just tackle it.